Imagine describing a robot in plain English and having it built, tested and ready to walk, all within a single day. No engineering background, no coding, just words. Welcome to Text-to Robot, a revolutionary AI system developed by researchers at Duke University in the United States. This cutting-edge platform takes natural language, like a six-legged robot that can climb stairs and walk over sand, and transforms it into a functional, walking 3D robot. It automates the entire design and simulation process, and the best part is that robot is ready for 3D printing and real-world use. That's not science fiction, it's today's breakthrough. To understand how groundbreaking this is, we need to look at where robotics came from. In the early days, robots were mechanical machines built by engineers using manual calculations and rigid designs. The process was expensive, slow, and demanded expertise in fields like electronics, mechanics, and software. Over time, simulation environments like ROS, Gazebo, and Mujoko made things a bit easier. Then came AI-assisted tools like MIT's RoboGrammer, which could generate digital robot models, but even then, users needed technical knowledge to go from simulation to something they could physically build. Text-to Robot changes everything. It brings a complete end-to-end pipeline that allows anyone, even non-engineers, to describe a robot in text. From there, a large language model interprets the input and begins constructing a digital 3D model. This model isn't just a rough sketch. It includes details like joint placement, actuator configurations, weight distribution, and most importantly, 3D printability. Once the structure is mapped, AI takes over again. Reinforcement learning and evolutionary algorithms are used to simulate and optimize the robot's movement. The robot is taught how to walk, how to balance, and how to perform the function it was built for. Everything, from its physical form to its control software, is co-designed. That's what truly sets Text-to Robot apart from its competitors. Most platforms focus on one stage, design or simulation or control logic. Text-to Robot handles them all. And because the output is designed with real-world constraints in mind, the robot can be printed with off-the-shelf materials using a regular 3D printer. Traditional robot development can take weeks or even months. It requires cross-disciplinary teams of experts. But with Text-to Robot, the process is fully automated, cutting development time to under 24 hours. And for educators, students, startups, or hobbyists, this is a game changer. In fact, the researchers behind this system are calling it a leap in human-machine interaction, comparable to the invention of the graphical user interface in personal computing. Just like GUIs allowed ordinary users to interact with computers through clicks instead of code, Text-to Robot allows users to build robots with words. Text-to Robot has already caught global attention. It's scheduled to be presented at the IEE International Conference on Robotics and Automation in May 2025, and it won first place in the innovation category at the 2024 Virtual Creatures competition. The future potential is massive. Think personalized elder care robots designed in a sentence, school projects where students invent their own robots without ever writing code, emergency response bots generated on the fly for specific environments. Even military and agricultural use cases are on the table. We're entering an age where robot creation may soon be as routine as designing a web page or writing a document. And Text-to Robot is leading the charge. So next time you imagine a robot that solves a problem in your home, your business, or your community, remember, the words you speak might be all you need to bring that idea to life. Thanks for watching. If you enjoyed this exploration into the future of AI and robotics, don't forget to like, subscribe, and share this video with anyone who loves innovation.